All right, first things first, we need to know upfront that pre-training is expensive. It is resource intensive, it is infrastructure intensive, time intensive as well. All pre-training means, okay, is that we're building a model from scratch, okay? And then we can kind of go into what from scratch means, okay? From scratch means that the model's weights are randomly initialized. So any number that will determine the model's behavior starts as noise, okay? It's not real, it's not inherited. The architecture or the actual scaffolding of the model exists, okay? But any of the inputs that go in are essentially, they're meaningless, okay? No inputs that go in actually mean anything at all. For LLM specifically, if we're talking about what we traditionally interact with, right, like ChatGPT, Claude, things like that, pre-training is training the model for text completion, okay? All right, so what comes next? All right, that is what we are focused on. Given some text, produce plausibly what comes next, right? Now, what happens during it? So the first thing that happens, and I'm just going to shorthand everything. The first thing that happens is that the model weights, like I said, are randomly initialized. So weights are initialized. All right. Every value starts as noise. Like I said, the model is given text. Okay. Then it predicts what comes next. Step 4 is that its prediction is compared to what actually came next. So there's a comparison, right, that happens. Step 5 is that the weights are adjusted to reduce error. So error reduction or weight adjustment, okay? And then steps 2 to 5 kind of repeat, all right, almost in a loop. All right, and they keep looping across an enormous amount of text, an enormous amount of times, all right? Those repetitions, all right, because we started with these kind of noisy weights, okay, they start shifting that noise to patterns of encoding, all right? So facts, anything that it creates some sort of structure. And they weren't specified, remember. Those were, none of that was specified. They emerge from this optimizing task over and over and over again. Now that run in and of itself, just to put things into perspective, all right, can eat up, let's say roughly 98% of compute, right? And that is my attempt at a computer chip or a CPU. So that eats into total compute and data used to produce the model, right? That can take a very long time. In this example, we're saying 98%, right? Like it's a lot of compute that run takes up. Now, a problem introduced early can go undetected until farther into the run, all right, with the compute having already spent, okay? So what we have, let's just say, those problems, although undetected, right, we can kind of deal with them later on. They might be expensive moving forward, but it's part of the process, right? We can go into the specifics about how to prevent those things from occurring, but this is essentially how this loop kind of works, right? And what comes out is an engine that accomplishes text completion. Okay, so that gives us, all of that gives us or equates to what we know as a base model, okay? That doesn't include anything that encompasses post-training, okay? We'll talk about post-training later, but this is a bare, we ran it through when a company like Anthropic or OpenAI, for example, says we have a new base model. This is the process that happens to get to that point. It's raw. It hasn't been fine-tuned, or the post-training hasn't happened, right? Excuse me, not fine-tuned. So now that we have our base model, all right, of all the training steps, I would say that step in and of itself is definitely the heaviest. All right, let's take Instruct GPT, for example. We utilized it in this example. This pre-training took up 98% of compute and data resources. Okay, so it takes a long time. The stakes can be fairly high because a small mistake here, like I said, can incur a very significant financial loss. We also don't know in these early problems that we experience whether or not they might be larger problems until farther down the pipeline, right? Most of this is an art. So pre-training, I would say on the whole, enterprises try and stay away from, because it's this from scratch method. It requires a lot of knowledge. It's an art form, people with pre-training expertise are very heavily sought after. So that skill, right, isn't learned necessarily through repetition, because not a lot of people get to do it. So it's it can be very, very hard to find people that can do it correctly, all right? So that in and of itself kind of encompasses everything that goes into this concept, right, of pre-training, okay? If you don't take anything else away, just know that all of these steps are expensive. They can take months, even up to a year, lots of compute power, lots of GPUs. In the next video, I will talk about fine-tuning. So I will create a video about fine-tuning and what the trade-offs are between pre-training and fine-tuning. Biggest one, right, if you can also take this kind of away, is like, there is a cheaper method of doing this. It's called fine-tuning, and it takes a base model, right, and kind of locks it into a room with a bunch of your own enterprise grade, kind of like what we would say is a vertical, right? Your own, let's say you're a legal, as an example, let's say you're a law firm, right? And you don't have a lot of time, you don't have the resources, you want to utilize AI, but you don't have an engineer who knows how to do something like pre-training, right? So what you do at that point is you take something off of the shelf and you fine-tune a model that already exists, a base model, all right? And you put it in a room with all of your legal documents, all of the things, all of the legal knowledge base that you have, and you introduce all of these things and you kind of pre-train an already existing model. There's downsides to that as well, though, and that's kind of why pre-training in and of itself can be a good thing for enterprises that can afford it. Pre-training helps you build a moat, right? At the end of the day, you also have these kind of like legal and compliance things that you have to take into consideration as well. So if you pre-train a model, right, and we get legislation that comes down from our government, having pre-trained, built a model from scratch, you know the inputs that go in, and you can legally back up the outputs that come out. This will become an issue over time because governments will regulate. The extent of that regulation is yet to be seen, but we're already seeing it in places like Europe, for example, where the European AI laws are very much they have constructed, kind of built a new, they're just new legal loopholes or legal things, legal roadblocks that companies have to kind of go through now in order to get their work done, because there are laws in place governing what AI can and cannot do. So again, kind of pros and cons to both approaches. This is what pre-training encompasses, though.